So let's look at another numerical question, and this is involving again orthogonal cutting or machining operation on mild steel. So the velocity is given, the rake surface angle is given alpha, width of cut is given, T1, that is the uncut chip thickness is given, and average mu, friction coefficient, and shear strength with respect to the material properties of mild steel are also given. Now we need to determine the shear angle, that is phi, and cutting and thrust component of the machining force. So let's start with the solving. So we are not given with enough values because we are not given with T2 value. So we are unknown with R, and so the R is also unknown. So in an equation where we had tan phi, so we had an equation of tan phi. So I'm writing this as tan phi is equal to R cos alpha upon 1 minus sine R sine alpha, 1 minus R sine alpha. So in this equation, there are two unknowns now. R is also unknown to us, or let me use this. R is also unknown to us, and phi is also unknown to us. So we cannot do this. We cannot use this equation to find the value of shear plane angle. So we are stuck over here. And in this situation, what we need to do is we need to assume the optimal solution. The optimal solution is the result of the minimum power which is required. So we'll assume the minimum power and merchant solution for that. So we are given with mu. So that is the lambda is known, that is tan inverse of mu. And now we'll assume the merchant's first solution. The merchant's first solution says the condition for minimum power is 2 phi plus lambda minus alpha is pi by 2. And from this relation, we have the value of alpha given. Lambda we found out from mu. So we get the value of phi. So now we are not using that analytical equations where we needed R and alpha value to get phi. We have used this another route to find the value of phi. That was coming because of the minimum power requirement condition. And the shear force now will be the shear strength which is given, and the areas W and T1 are already known. Phi we have estimated right now. So we get the shear force from the triangle. We now have the shear force. We now have the angle phi, lambda, and alpha. So from the triangle, we can find the value of R. From R, we can find the value of FC also, FT also. Wow, how? Because that FC and FT are also having that equivalent force as R. So this is one of the triangle. And now we have the value of R. So we can use that value of R, F, and this is the R which we have. This is the FC which we have, and FT. So we have the R value and we have this angle lambda minus alpha known to us. So now we can find the two unknown sides. So that's what we have done. R cos projection and FT will be R sine projection. So that's all we have. So here you have understand that if we are not given with enough conditions, we can assume the condition for minimum power requirement. But you should be careful. You cannot directly start with using these conditions. This is only applicable if the initial conditions or whatever input parameters you are given are not enough to solve the question. So we'll stop over here. Thank you.